A very warm welcome to my viewers. I am Aravind Balaji. This is CodeSentinel, my Info 7375 final project at Northeastern University. It is a multi-agent AI system for code review. The claim is simple. Single prompt LLM code review has a hallucination problem. Models invent plausible sounding vulnerabilities that don't exist. In my benchmark, a single prompt baseline on Claude Sonnet produced 30 false positives across 10 samples. My multi agent pipeline using the same Claude Sonnet and the same prompts produced one. Same model, different architecture, 97% fewer hallucinations. In the next 7 minutes, I'll show you three things: the architecture, three specialized agents with a citation enforcing guardian, the live demo, a real deployment you can try yourself, and the measured result, a 97% reduction in false positives, backed by the full benchmark output from April 20th, 2026. Let's go through the architecture. Three agents, one shared states, one lang graph orchestration. The security sentinel finds vulnerabilities. It is RAG grounded. It queries a local index of 56 passages from OWASP top 10 and the CVE taxonomy before emitting any finding. Every finding must cite a retrieved passage. No citation, no finding. The code quality auditor handles style and maintainability, capped at 10 findings per file. And the Evaluator Guardian is the interesting one. It's the piece that turned 30 hallucinated baseline findings into one. Now let's see how the Evaluator Guardian is programmed. So this is Evaluator Guardian.py. The evaluator has two layers of rejection. Layer 1 is a programmatic check. Does the finding cite a passage the retriever actually returned? Is the confidence above 0.5? Is there a concrete fix? If any check fails, the finding is rejected with a specific reason, and the upstream agent gets 3 retries with feedback before a circuit breaker terminates. The layer 2 runs only if layer 1 passes. It is an LLM semantic check. Does the cited passage actually support this claim? This is how the architecture rejects hallucinated findings before they reach the user. It is also the architectural pattern Anthropic's Project Glasswing used to find 0 days at industrial scale. Same pattern, different scale. Now let's see some live demo. So let me paste the sample code I have. and click on Analyze. This is the live deployment on Streamlit Community Cloud hitting real Claude Sonnet. The URL is in the web page and the README and the documentation. Anyone can try it. The sample is 6 lines of Python. It calls YAML.load on user input. That's CWE 502 deserialization of untrusted data, arbitrary code execution. So now the security sentinel is analyzing. Let's wait for some time. There are the results here. This is CWE 502 OWASP A08 2025. The confidence score is 0.94. And notice the citation at the bottom, patterns.md passage pi08. If the security sentinel had cited a passage the retriever didn't return, the evaluator would have rejected this finding. That's the structural defense against hallucination running live. Now let's see the summary of results. These are the numbers from the full benchmark run on April 20th against real Claude Sonnet. 10 samples, 8 ground truth findings. Single prompt baseline, true positive rate 1.0. Caught everything. But look at the false positives, 30, an average of 3 hallucinated findings per sample. These aren't obvious fabrications. They cite plausible CWEs. They sound confident. They are the exact failure mode a tired reviewer approves at midnight. Multi-agent CodeSentinel also 1.0 true positive rate. Caught the same 8 real vulnerabilities, but the false positives dropped from 30 to 1. False positive rate from 0.789 to 0.11. Same underlying LLM. Same prompts to the LLM. The Evaluator Guardian's citation enforcement rejected 29 of the 30 hallucinated findings before they reached the user. So this is the technical report. Let me scroll down. Here I want to talk about an important piece. The bug the system caught. So I'll be going to the specific section for that. So let's go to page number 19. Yeah. One story the report tells that I want to leave you with. During the development, my mock LLM was hard-coded to cite CWE327 for MD5 findings. That's the correct CWE. The citation looked plausible, but the evaluator rejected the finding because the retriever had surfaced a different passage. from the patterns.md pi08 for MD5 queries. Here is the mention of it. The evaluator saw a citation to a passage that wasn't retrieved. It rejected correctly. The fix was 3 characters. Change the mock to cite the passage the retriever actually returns. No policy was relaxed. The system caught its own bug before I did. That's section 11 from the report, and it is the moment I knew the architecture was doing the work. The rubric of the final project requires 2 out of the given 5 generative AI components. This project implements 4. Prompt engineering, 3-role specialized system prompts with explicit contracts, retrieval augmented generation, 56 passages, 3-tier backend fallback, citation enforcement, synthetic data generation, 15 CWE templates with an independent regex-based verifier, 29 of 30 samples pass, and the one rejection is evidence the verifier is genuinely independent, and a reinforcement learning demonstration module. One honest note on the reinforcement layer. It's in the repo. It converges on synthetic reward surfaces, but it is not wired into the production agent graph. The benchmark numbers I showed you do not depend on it. That's disclosed in 4 places in the submission. A reinforcement learning integration is future work, not a claimed contribution. I also ran SemGrep, the industry standard open source static analyzer, as a control against Flask production source. Both tools returned 0 findings on clean code. That's the correct result. It shows the multi-agent system doesn't over-trigger, which matters because the baseline LLM produced 3 false positives per file on adversarial inputs. I am not claiming this replaces SemGrep, which has a decade of rule development, or CodeQL, which does data flow reasoning this system lacks. What this project does is close 3 specific failure modes of single prompt LLM review: hallucinated vulnerabilities, silent omissions, and untraceable findings. The 30-to-1 result is the direct measurement, and this is my honest claim. CodeSentinel, real Claude Sonnet, same model, same prompts, different architecture. False positive rate from 0.789 to 0.11, 35 tests passing, a live deployment you can try yourself at the URL in the web page, and 1 bug caught by the system itself before I caught it. The code is on GitHub, the report is in the repo, the live demo is 1 click away in the website. Thanks for watching.